Dear students of class 9 and 10, in this video I have discussed the complete concept of probability. I have started with the concept of probability, took some textbook examples to make the concept more clear, and I have answered the complete NCERT textbook exercise questions. So this one video on the topic probability will be more than enough if you are attempting the class 10th board examination. So watch this video until the end to have a complete concept understanding on the topic probability. Now let us begin with the topic of probability. What could be the meaning of the word probability? The extent to which an event may occur. That means either 50% or 30%. That means probability of happening or not happening of an event will be in form of a fraction. So the extent to which an event may occur or not occur is known as probability of an event. We can classify probability as theoretical probability and experimental probability. Theoretical probability is that what we are studying right now. That means by theory, say a coin is tossed once. So what is theoretically the probability of getting a head or a tail? When one coin is tossed once, either you may get a head or you may get a tail. So the chances of getting a head is one out of the two choices, head and tail, and the probability of getting a tail is also one out of the two choices. The two choices are head or tail. So 50-50% chances are there to get a head or a tail. So that is a theoretical probability. And what about experimental probability? Experimental probability would mean that when you conduct an experiment like a tossing of a coin once, when you toss it say for the first 50 times, and all the 50 times there is more chances that you get a tail and get no head, but you will get the 50% probability of getting a head or a tail during the experiment of tossing a coin once when you conduct more number of experiment. Say a coin is tossed 1000 times, then the chances are there that 500 times you get a head and another 500 times you get a tail. So experimental probability will become equal to theoretical probability when the number of times an experiment that is performed is more. So we are studying in our textbooks the theoretical probabilities. Now moving ahead, we will use the representation P in the bracket E for probability of happening of an event, and P in the bracket E vinculum for probability of not happening of an event or the probability of a complementary event. Now let's come to the definition of a probability of happening of an event. Probability of happening of an event is the ratio of the number of favorable outcomes of an event to the total number of outcomes of that event. Since the probability of happening of an event is the ratio of the number of favorable outcomes of an event to the total number of outcomes of an event, we will know the total number of outcomes and favorable outcomes if we write every event's sample space. What is the meaning of sample space? Sample space is the set of all outcomes of an event. Now let's write the sample space for tossing of a coin, rolling of a dice, about the playing cards, and about the days of a regular year and a leap year. Let's see how to write the sample space for tossing of a coin. The first case where a coin is tossed once. If a coin is tossed once, then either a head shows up or a tail shows up. The second case where two coins are tossed once. Remember that two coins tossed once is the same as a single coin tossed twice. How to write the sample space? You can write along the horizontal line the outcomes of the first one coin which is tossed once, that means head and tail, and along the vertical line write the outcomes of a single coin which is tossed once. So here we have the first coin information, and in the vertical line we have second coin information. So the outcomes may be head head, head tail, tail head, or tail tail. So when two coins are tossed once, the outcomes which we write in form of sample space are head head, head tail, tail head, tail tail. So here we have 4 total number of outcomes. Now in third case, where 3 coins are tossed once, 3 coins tossed once is the same as a single coin tossed 3 times. And how to write the sample space for this? Along the horizontal line, we will write the outcomes of 2 coins which are tossed once. That means head head, head tail, tail head, tail tail. And along the vertical line, we will write the outcome of a single coin that is tossed once. That is a head and tail. So along the horizontal line, we have information of 2 coins, and along the vertical line, we have information of a single coin. So this will give us the outcomes of 3 coins which are tossed once. So we may get head head head, head head tail, head tail head, head tail tail, or tail head head, tail head tail, tail tail head, tail tail tail. So totally 8 number of outcomes. So the sample space consists of triple head, 2 heads and a tail, head tail head. This means that on the first coin we find head, on the second coin we find tail, on the third coin we find head. And the fourth outcome, head tail tail, then tail head head, tail head tail, tail tail head, and triple T. So we saw how the sample space is written. Now, without writing the sample space also, in case of tossing of a coin, we can write the total number of outcomes. But we should write the sample space to find the favorable outcomes. So there is a shortcut formula by which we can know the total number of outcomes in case of tossing of a coin. Since a coin has 2 faces, so we will write 2 to the power n, and n is the number of tosses. Now let's check this formula. In the first case, a single coin is tossed once, so total number of outcomes is 2 to the power number of tosses, that is 1. So here 2. So here sample space has 1 and 2. So 2 number of outcomes. In the second case, 2 coins tossed once. 2 coins tossed once is the same as a single coin tossed 2 times. So 2 to the power number of tosses. Single coin is tossed 2 times. 2 to the power 2 is 4. So here we have 1, 2, 3, 4. 4 number of outcomes. In case of 3 coins tossed once, total number of outcomes is 2 to the power 3. Because 3 coins tossed once is same as 1 coin tossed 3 times. So 1 coin means 2 raised to the power 3, that is 8. And here the total number of outcomes is 1, 2, 3, 4, 5, 6, 7, 8. In case of a rolling of a dice, let us write the sample space. If a single dice is rolled once, then the elements of sample space will be 1, 2, 3, 4, 5, 6, one of them. So one single dice rolled once will have 6 total number of outcomes. Now let's see if 2 dice is rolled once. 2 dice rolled once is the same as a single die rolled twice. How to write the sample space? For that, along the horizontal line, we have to write the outcomes of the single die that is rolled once. That is a 1, 2, 3, 4, 5, 6. And along the vertical line, we have to write the outcomes of a single die that is rolled once. When we write like this, we will get the total number of outcomes for 2 dice which is rolled once or a single die that is rolled twice. So in case of 2 dice rolled once or 1 die rolled twice, the outcomes will look like this. That means on the first die we may get 1 and on the second die also we may get 1. Or on the first die we get 1 and on the second die we get a 2. So like that, the first number is the outcome on the first die and the second number is the outcome on the second die. So total number of outcomes when 2 dice are rolled once is 6 along horizontal and 6 along vertical, so total 36. So without writing the sample space also, we can find the total number of outcomes. But we write the sample space to find the favorable outcomes. Now, how to find the total number of outcomes? The total number of outcomes in case of a die which is rolled once or twice is a die has 6 faces. So 6 to the power the number of rolling it is done. So n stands for how many times the die is rolled. Now let's check this formula. In the first case, when a single die is rolled once, so single die has 6 faces and it is rolled only once. So 6 to the power 1 is 6. So total number of outcomes is also 6. So total number of outcomes is going to be the denominator part of the probability that we are going to find as the video proceeds. In the second case, when 2 dice are rolled once, 2 dice rolled once is same as a single die rolled twice. So in this case, the total number of outcomes is the single die has 6 faces and this is rolled twice. So 6 square is 36 and here we have the 36 outcomes in all. Now consider the case of a well-shuffled deck of playing cards. A well-shuffled deck of playing cards consists of 52 cards. The 52 cards will be of 4 kinds of 2 different colors. To make the understanding and remembering easy, I kept towards the end the black colored cards. The black colored cards are the spade and club, and in the center I kept the red colored cards. In a well shuffled deck of playing cards, we will have a spade. The spades look like this and the club looks like this. The spade and club always appear in black color. Then diamond looks like the way you see on the screen, the diamond shape, which is a red in color always, and a heart is also always a red in color. Under each kind there will be 13 cards, means there are 13 spades, 13 diamonds, 13 hearts and 13 clubs. Just we have to remember that the spade and club appear in black color, diamond and heart appear in red color, with each kind of card 13 in number. Each of the cards consists of king, queen, jack. The king, queen, jack are called the face cards. After jack, we will have the number cards 10, 9, 8 and it goes in descending order 3, 2. So the number cards will be from 2 to 10. After 2 there will be no one numbered card but we'll have an alphabet card A. The alphabet card is the ace card. So under each kind of the card there will be king, queen, jack. So there will be totally 3 fours, 12 face cards, 10 to 2. 9 number cards of each kind, so 9 into 4, so there will be 36 number cards, and under each kind of card there will be a single ace card, so there will be 1 into 4 kinds, so 4 ace cards. So 12 plus 36 plus 4 makes a 52 cards. Now we are almost there to calculate probability of happening of an event. So the last slide about sample space would be the days of the year. About the days of the year, there are two types of years. Regular year, which has got 365 days, and a leap year, which will have 366 days. Also, we know that a week has 7 days. So when we divide 365 by 7, we will get the number of weeks a year has. So 7 5s 35. We have 1 as the difference and 5 drop down. 7 2s 14 and 1. So a regular year has 52 weeks and 1 extra days. Coming to leap year, when we divide 366 by 7, we will get 2 as a reminder. That means a leap year has 52 weeks and 2 extra days. Now let's try to answer the probability of having 53 Sundays in a regular year. So in a regular year, there are 52 weeks. So 52 weeks for sure will have 52 Sundays. But what is the probability of having 53 Sundays? So 52 weeks will give us 53 Sundays, and if this extra day is also a Sunday, then a regular year will have 53 Sundays. So we have to write the sample space for this one day and search for a Sunday in this extra one day. So that one day can be a Sunday, a Monday, a Tuesday, a Wednesday, a Thursday, a Friday, or a Saturday. So there are 7 outcomes in this sample space. So probability of having 53 Sundays will have a total number of outcomes as 7, because we should test for that one extra day to be a Sunday or not to get 53 or 53rd Sunday. So 7 out of 7, there is only one case where we see a Sunday. So 1. So probability of having 53 Sundays or Mondays or Tuesdays in a regular year is 1 out of 7. Now let's answer the second bit. What could be the probability of having 53 Sundays in a leap year? 53 Sundays in a leap year. So a leap year has 52 weeks. So 52 weeks will have 52 Sundays. Now we should try for the 2 extra days. What could be the sample space for the 2 extra days? The 2 extra days can be a Sunday-Monday combination, or a Monday-Tuesday combination, or a Tuesday-Wednesday combination, Wednesday-Thursday combination, Thursday-Friday combination, Friday-Saturday combination, or Saturday-Sunday combination. Now, in a leap year, what is the probability of having 53 Sundays? So as I said, 52 weeks will have 52 Sundays. So the 53rd Sunday, we have to search in the 2 extra days. In the 2 extra days, we see in this combination we see a Sunday, and in this combination we see a Sunday. So there can be 2 choices where we can see a Sunday out of the 7 choices in this sample space. So the probability of having 53 Sundays in a leap year is 2 out of 7 choices. Now coming to the third question. What is the probability of having 52 Sundays in a regular year as well as a leap year? So first let us answer for a regular year. What is the probability of having 52 Sundays? Now remember that in a regular year there are 52 weeks. So 52 weeks will give us 52 Sundays. Now we have to see that that extra day should not be a Sunday for getting 52 Sundays in a regular year. So what is the probability that that extra day that we see in a regular year is not a Sunday? So how many no Sundays are there in that extra day? So the no Sundays are 6 out of 7 outcomes of the 1 day sample space. So the probability of having 52 Sundays in a regular year is 6 out of 7. Now let's answer the probability of having 52 Sundays in a leap year. Now watch the leap year information. So we want 52 Sundays in a leap year. So 52 weeks will have 52 Sundays. Now we have to see that the 2 extra days should not be Sunday. So among the 2 extra days sample space, we have to search for all those outcomes which do not have a Sunday, so that we can have 52 Sundays. So there are 5 outcomes which are no Sunday outcomes. So 5 out of 7. So probability of having 52 Sundays in a leap year is 5 out of 7. Having understood the method of writing sample space for various events, now let us try to understand the meaning of elementary events and how elementary events are connected to the probability of a sure event and probability of an impossible event. To understand this, consider the case of tossing of a single coin only once. Then the outcomes in the sample space will be either a head or a tail. Then probability of getting a head is 1 out of the 2 choices. And probability of getting a tail is also 1 out of the 2 choices. In case of a single coin tossed once, the elementary events are a single head and a single tail. So the sum of probabilities of the elementary events is always 1, indicating that in case of a coin which is tossed once, for sure we get a head or a tail. So probability of a sure event is always 1. On the similar lines, when a coin is tossed once, what is the probability of getting a number 6? Since in case of a coin we don't get the number 6, so the favorable outcome is 0 out of the 2 outcomes. The 2 outcomes are head or a tail. So 0 by 2 is 0. So probability of getting a number 6 or getting a certain card color or card number is completely 0. So this is the probability of an impossible event. In case of a dice rolled once, the sample space will consist of numbers 1 to 6. Then what is the probability of getting a number less than 4 when a dice is rolled only once? Less than 4 means we consider 1, 2 and 3. So 3 out of the 6 choices means 1 by 2. And what is the probability that we get a number greater than 4? Numbers greater than 4 are 5 and 6. So the probability of getting a number greater than 4 will be 2 out of the 6 cases, that is 1 by 3. Now, do we consider this probability of number less than 4 and a number greater than 4 as elementary events? These two are not considered as elementary events because in the first case we are considering a number less than 4. That means we are considering 3 outcomes of an event. So 3 can't be elementary. Elementary is each of the single case of the outcome of an event. Similarly, probability of getting a number greater than 4. So here 2 numbers are involved. So this is also not an elementary event. And hence sum total of a probability of getting a number less than 4 and getting a number greater than 4 will not sum up to 1. Now the cases of probability of getting a number 1 or 2 or 3 or 4 or 5 or 6 is 1 out of 6. So what is the probability of getting a number 1? Is 1 out of the 6 cases. So these are called the elementary events, and sum of all these elementary events probability will surely turn up to be 1. That means 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 will sum up to 1. That means when a dice is rolled once, surely we will get 1 out of the 6 numbers. Now summarizing what we have learnt in this slide is the sum total of probabilities of all the elementary events is always a 1. So that is a verification. That means if the sum is not turning 1, then we are not talking about the probability of elementary event. And the probability of a sure event is always a 1, and probability of an impossible event is always 0. Say for example, in case of a dice that is rolled once, what is the probability of getting a head or a tail? So in a dice there is no outcome which is a head or a tail. So it is a 0 out of the 6 cases. So 0. So this is the probability of an impossible event. That means it is impossible to get a head or a tail when a dice. So finally, probability of occurrence or happening of an event always lies between 0 and 1. So in the first case, when we were finding probability of getting a head, we had a 1 by 2. 1 by 2 is 0.5. 0.5 lies between 0 and 1. Similarly, probability of a number less than 4. Similarly, probability of getting a number less than 4 was 3 out of 6 cases. That is also 1 by 2, which is 0.5, lies between 0 and 1. And probability of a number greater than 4. Greater than 4 was 5 and 6. So 2 out of 6 cases, which was a 1/3. 1/3 is 0.3. That is also a number that lies between 0 and 1. So probability of happening of an event always lies between 0 and 1. And probability of happening of an event plus the probability of not happening of an event is 1. That is probability of happening of an event, sure event, plus probability of not happening of an event. That is probability of an impossible event. So 1 plus 0, which is 1. So probability of happening of an event plus probability of its complementary event is always 1. Now let's come to the textbook part of probability, chapter 14. It begins with a nice quotation here. The quotation says, the theory of probabilities and theory of errors now constitute a formidable body of great mathematical interest and of great practical importance. R.S. Woodward. And you see a picture of Pirate Simon Laplace, and here a small paragraph on the theoretical approach done by him in the book of Games of Chance. So give a read of this. We will go to the application part of it. Here is an application of probability. The question says a bag contains a red ball, a blue ball and a yellow ball. All balls are of same size. Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out a yellow ball, a red ball or a blue ball? Since we know that probability of occurrence of an event, so in the first bit, occurrence is a yellow ball, is always the number of favorable outcomes divided by total number of outcomes. Here favorable outcomes is how many yellow balls are there in the bag. So there is only one yellow ball in the bag out of 3 different colored balls. So probability of getting a yellow ball is 1 out of 3 cases. The second one, what is the probability that when Kritika picks up a ball randomly from the bag, she gets a red ball? So similarly, red, there is only exactly 1 red ball out of the 3 balls in the bag. So probability of getting a red ball is 1 out of 3. And in the third case, what is the probability of getting a blue ball? Similarly, blue is also 1 colored ball out of the 3 colored balls. So These are the elementary events of probability of happening of an event. And since we know that probability of all the elementary events is always 1, that means probability of getting a yellow ball plus probability of getting a red ball plus probability getting a blue ball is 1/3 plus 1/3 plus 1/3, which turns out to be 3 times 1/3 and which is 1. This indicates that when we put our hand in the bag to pull out one of the balls, for sure we are going to get a yellow or a red or a blue ball. And these three probabilities, decimal representation is 0.3. This indicates that probability of happening of an event always lies between 0 and 1, since this number 0.3 lies between 0 and 1. So probability of occurrence of an event always lies between 0 and 1. 0 is for impossible event and 1 for sure event. Here there is one more application of probability. Suppose we throw a die. So here I have written the sample space for a die when it is a rolled 1. So then we either get a number 1 or 2 or 3 or 4 or 5 or 6, since a die is a cube of 6 faces with numbers in form of dots inscribed on it. The question is, what is the probability of getting a number greater than 4? That is the first bit. And what is the probability of getting a number less than or equal to 4? Let us answer the first bit. What is the probability of getting a number greater than 4? Now, probability of happening of an event is a number of favorable outcomes divided by total number of outcomes. So here total number of outcomes is 6. So denominator is decided. How many numbers are greater than 4? Here 5 and 6. So there are only 2 numbers which are greater than 4. So probability of getting a number greater than 4 is 2 out of 6, which is 1/3. In decimal form it is 0.3. The second one, what is the probability of getting a number less than or equal to 4? So here sample space, number of events in sample space is 6. So denominator is the total number of outcomes, that is 6. And how many of them are less than or equal to 4? Equal to 4 is 4 and 3, 2, 1 are less than 4. So these are 4 out of 6. In standard form it is a 2/3 or it is 0.6. Here there is one more application on probability. The question is, Savita and Hamida are friends. What is the probability that both will have different birthdays and same birthday, ignoring that it is a leap year? Since we know that the number of days in a regular year is 365 days, so 365 days is the total number of outcomes. Now to answer the first one, what is the probability that both of them have different birthdays and probability that they have same birthday? Let us answer the second bit first. Probability that both of them have the same birthday is 1 out of the 365 days. In that case, probability of both of them having different birthdays will be the remaining days other than that one day. That means 364 out of 365 days. The probability of different birthdays can also be calculated using the formula probability of happening of the event plus probability of not happening of the event is equal to 1. Here, probability of both of them celebrating birthday on the same day can be considered as probability of happening of an event, and probability that they don't celebrate birthday on the same day can be considered as probability of the complementary event. In that case, if probability of happening of the event is probability of both of them having same birthday is 1 out of 365, then using the identity probability of happening of an event plus probability of a complementary event is equal to 1. In place of probability of happening of the event, we can write 1/365 plus probability of not happening of the event, means not same birthday, means birthday on different days, is equal to 1. On transposing 1/365, we'll get probability that both of them have a birthday on different days is 364 out of 360. Here there is one more application question. The question says there are 40 students in class 10 of a school, of whom 25 are girls and 15 are boys. The class teacher has to select one student as a class representative. She writes the names of each student on a card, cards being identical. Then she puts the cards in a bag and stirs them thoroughly. She then draws one card from a bag. We have to answer the question, what is the probability that the name written on a card is the name of bit 1 girl, bit 2 a boy. Since we know that probability of happening of an event is the number of favorable outcomes divided by total number of outcomes. So total number of outcomes is 40, since there are 40 students in the class. Number of favorable outcomes will be, for the first bit, how many girls are there? So there are 25 girls. And for the second case, number of favorable outcomes will be the number of boys in the class, that is 15. Now these fractions we have to bring to standard form, further in decimal to get our answer in standard form. 25 divided by 40 is 0.625 and 15 upon 40 is 0.375. Now here, probability of happening of an event, this number as well as this number are lying between 0 and 1, that is 1 point. Number 2, this question's elementary events are having a girl named card and having a boy named card. So the sum of probability of all the elementary events is always 1. Now when we add these probabilities, we are going to get 1. Let's check it. So 0, here once again 0, and here 0, and we are getting 1. So probability of sum of all the elementary events is always 1. It indicates that in this kind of a question, when a card is picked up, it is for sure a girl named card or a boy named card. Here there is one more application of probability. The question says, Harpreet tosses the 2 different coins simultaneously. So the sample space for 2 coins tossed simultaneously is a head-head, head-tail, tail-head or a tail-tail. The question is, what is the probability that she gets at least 1 head? The total number of outcomes is 4 and number of favorable outcomes we have to select out of these 4. So at least 1 head. At least 1 head means maximum heads to 1 head. So here maximum head is a 2 and 1 head case is this and this. So number of favorable outcome is a 3. The probability of at least 1 head is 3 out of 4 choices, which is 0.75, and this probability 0.75, this probability of happening of an event lies between 0 and 1, that is between impossible and sure. Moving on to the next example question. The question is, in a musical chair game, the person playing the music has been advised to stop playing the music at any time within 2 minutes after start. What is the probability that the music will stop within the first half minute after start? The probability that the music stops within first half minute after start is half minute over the total duration at which the music has to restart, that is 2 minutes. So it is 1 upon 4, which is 0.25. And probability of happening of this event is also lying between the impossible to sure case. Coming to the next application on probability, the question states a carton consists of 100 shirts, of which 88 are good and 8 have minor defects and 4 have major defects. Jimmy, a trader, will only accept shirts which are good, but Sujata, another trader, will only reject shirts which have major defects. One shirt is drawn at random from the carton. What is the probability that it is acceptable to Jimmy? And second bit, it is unacceptable to Sujata. So Jimmy accepts the shirts which are good, and there are 88 good shirts out of 100. So the probability that it is acceptable to Jimmy is 0.88, and Sujata will reject shirts when they are which have major defects. So there are 4 shirts with major defects. So they are not acceptable to Sujata. So Sujata can accept good shirts as well as shirts with minor defects. 88, that means she accepts all good and or the shirts with minor defects. That is 88 plus 8 over the 100 shirts. So the probability that the shirt is acceptable to Sujata is a 96 over 100, which is a 0.96. Here there is one more application of probability. The question states that 2 dice, one blue in color, another grey in color, are thrown at the same time. Write all the possible outcomes. So we are supposed to write all the possible outcomes to get our sample space. So when 2 dice are rolled once or 1 dice is rolled twice, in the concept part of the video, the before part, I have already discussed how to write the sample space. Here I have a cutout of the sample space. So one of the dice outcomes are 1, 2, 3, 4, 5, 6, which we write in horizontal, and the second dice outcomes that is 1 to 6 is written along the vertical line, and the combination is in this form. That means on the first die we may get a 1 and on the second die we may get 1, or something like on the first die we get a 6 and on the second die we get a 5. So this is how we write the sample space for 2 dice rolled once. Now the question is, what is the probability that sum of 2 numbers appearing on the top of the dice is 8? So we have to see that when we roll 2 dice together, the sum of digits that appear on the top is 8. So here already it is being outlined. So these are 6 plus 2 is 8, 5 plus 3 is 8, 4 plus 4 is 8, 3 plus 5 is 8, and 2 plus 6 is 8. So probability that the sum of 2 numbers is 8 is 5 out of 36 cases. The second bit is, what is the probability that the sum of 2 numbers appearing on the top of the 2 dice is a 13? 13 is not possible. Why? Because the minimum sum is a 1 plus 1, that is the 2, and the maximum is a 6 plus 6, that is the 12. So the sum of numbers appearing on both the dice can never be 13. So it is a 0 possibility out of the 36 possibilities. So it is a 0, and this is the case of the probability of an impossible event. And the third bit of the question is, what is the probability that the sum of the 2 numbers appearing on the top of the dice is less than or equal to 12? So here all the numbers appearing on the top is less than or equal to 12. That means the maximum number that we will get is 6 plus 6 is 12, and it means that all the numbers in this sample space is something which sums up to 12 or less than 12. So it is all 36 cases out of the total 36 outcomes, which is a 1. That means when 2 dice are rolled once, then the sum of 2 numbers appearing on top of the dice will surely be 12 or less than 12. Now we have arrived at exercise 14.1. The first question, complete the following statement. The first bit says, the probability of an event plus the probability of not an event is equal to dash. So it is always equal to 1, because probability of happening of an event plus probability of not happening of an event means complementary event is always 1. This we have discussed in the beginning part of the video. The second bit, the probability of an event that cannot happen is always 0. Such an event is called an impossible event or a complementary event. The third bit, probability of an event is certain to happen is always 1, and such a event is called a sure event. The fourth one, the sum of probabilities of all elementary events of an experiment is always 1. The last one, the probability of an event is greater than or equal to 0 and is less than or equal to 1. Its meaning is probability of happening of an event is always lies between 0 and 1. Greater than 0 and less than 1, 0 and 1 are included. The second question, which of the following experiments have equally likely outcomes? Means in case of a tossing of a coin once, there is equal likeliness of getting a head or a tail. So keeping that in mind, we will answer these. The first one, a driver attempts to start a car. Then the car starts or it does not start. True, this is equally likely outcome. The second one, a player attempts to shoot a basketball. So she or he shoots or misses the shot. That's also equally likely. The third one, a trial is made to answer true or false question. The answer is right or wrong. That's also true. And then the last one, a baby is born. It is a boy or girl. So when a baby is born, it is more likely that it is a boy or a girl. So both are equally likely outcomes. The third question, why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of the football game? So tossing a coin is considered to be a fair way of deciding because when a coin is tossed, either it is a head or a tail. So there are exactly two outcomes and a team can choose one of the outcome. In that case, both the teams will have the 50-50 chances, 50-50 percentage chances of winning it. So that will be a fair way of deciding factor. So winning or losing in such a case is a 50-50. So both the teams have the equal share of winning or losing. So it is a fair way of deciding. The fourth one, which of the following probabilities or which of the following cannot be probability of happening of an event? While answering this, keep in mind, probability of an event is greater than or equal to 0 and less than or equal to 1. That means it should lie between 0 and 1. So the first one, 2 upon 3. So this is a number which is less than 1. So this is possible. We should say which is not possible. The second bit, probability of an event is minus 1.5. So this is not possible. Probability of happening or not happening of an event can't be negative. The third one is 15%, means 0.15. So this is also less than 1. It is possible. The last one, 0.7, which is less than 1, that is also possible. So which cannot happen? The B bit. The B bit, which is minus 1.5. So probability of an event cannot be negative of a number. The last one, probability of happening of an event is 0.05. What is the probability of not happening of the event? So probability of not happening of an event is 0.95. Now the sixth question of exercise 14.1. The question states, a bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy? First one, since the bag contains lemon flavored candies only, the probability of getting an orange flavored candy is completely 0. So this one is the probability of an impossible event. The second one, what is the probability of getting a lemon flavored candy? This is the probability of sure event. Why? Because the bag contains only lemon flavored candies, and when we put our hand to pick up one of the candies, we are sure to get a lemon flavored candy. So probability of lemon flavored candy is 1. Now the seventh question, it is given that in a group of 3 students, the probability of 2 students not having same birthday is 0.992. What is the probability that the 2 students have same birthdays? Since we know that probability of happening of an event plus probability of the complementary event, means not happening of an event, is 1. So probability of not having same birthday plus probability of having same birthday should be 1. In place of probability of not same birthday, we will substitute 0.992 and get the probability that the two students have same birthday. Now we will transpose 0.992 to the other side, and 1 minus 0.992 will be the answer, which is 0.00. Now the 8th question. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is a red ball? So probability of happening of an event is the number of favorable outcomes divided by the total number of outcomes. So every time before answering the question, we have to write this formula, and then we have to write the number of favorable outcomes, then total number of outcomes, and then the final answer we have to put it in form of fraction, which I am writing it now. The probability of getting a red ball is 3 out of 3 plus 5, that is 8 balls. And the probability that it is not a red ball, means it is a black ball, is 5 out of 3 plus 5, the total number of balls, that is 5 by 8. We can represent the last answer in form of decimal to give a verification that probability of occurrence of an event lies between 0 and 1. The 9th question. A box contains 5 red marbles, 8 white marbles and 4 green marbles. 1 marble is taken out of the box at random. What is the probability that the marble taken out will be the red one? As I said before answering, first write the formula which is used to calculate probability of happening of an event, which is the total number of favorable outcomes divided by the total number of outcomes. So here, after writing that step, we should write the first bit answer, that is probability that it is a red marble. So how many red marbles are there? 5. 5 out of the total number of marbles in the box, that is 5 plus 8 plus 4, which is 17. Now the second bit, what is the probability that it is a white marble? White marbles are 8 in number out of the total 17 marbles. And the third one, what is the probability that it is not a green marble? If it is not a green marble, it is a white marble or a red marble. So total number of red and white marbles is 5 plus 8, which is 13 out of the total number of marbles in the box, that is 17. So this is the probability of happening of these events. The question number 10, it states a piggy bank contains 100 50 paisa coins, 50 rupees 1 coins, 20 rupees 2 coins and 10 rupees 5 coins. 5 rupees coins. If it is equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paisa coin in the first bit and in the second bit will not be a 5 rupees coin? So answering the first one, so we have to first, while answering, write the formula that we use to find probability of happening of an event. And then the first bit is probability that it is a 50 paisa coin. So how many 50 paisa coins are there? They are 100 in number out of the total number of coins in the piggy bank, which is 100 plus 50, that is 150, plus 20, 170, plus 10, that is 180. So there are in all 180 coins. Just verify this. 100 plus 50 is 150. 150 plus 20 is 170 plus 10 180. So this turns out to be 10 by 18, which is 5/9, and this is a number less than 1. So this can be probability of happening of an event. The second bit is, what is the probability that it is not a rupees 5 coin? So it should not be rupees 5 coin. If it is not 5 rupee coin, it should be those 100 50 paisa coins, or those 50 1 rupee coin, or the 20 rupees 2 coins out of the 180 coins. So this turns out to be 170 by 180, which is a 17 over 18. This also is a number less than 1. Now the 11th question. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at a time at random from the tank containing 5 male fish and 8 female fish. We have to see this diagram that is shown here. What is the probability that the fish taken out is a male fish? So once again we should write the formula first, and then we should answer the probability of getting a male fish out of fishing from the aquarium, fishing for the aquarium. So there are 5 male fishes out of the total number of fishes. So there are 5 male fishes and 8 female fishes. So probability of getting a male fish is a 5 out of 13. This, when we convert to decimal form, it will be a number less than 1, or something that lies between 0 and 1. Now answering the 12th question. The question says a game of chance consists of the question states that the 12th question, a game of chance consists of spinning an arrow which comes to rest pointing one of the numbers from 1 to 8, and we are asked to refer to this figure 14.5. Each of these are equally likely outcomes out of 1 to 8. We have to answer this. What is the probability that it will point at 8? So how many 8s are there? It is a 1 8. So probability of getting an 8 is 1 out of the 8 numbers that is there on this dashboard. The second one, what is the probability that it is an odd number? So out of 1 to 8, how many odd numbers are there? 1, 3, 5, 7. So it is 4 out of 8, which is 1 out of 2, which is a 0.5. And then the third bit, what is the probability that we get a number greater than 2? Number greater than 2 is a 3, 4, 5, 6, 7, 8. So these are 6 in number. So the probability for the third bit is 6 out of 8, which is a 3 out of 4, 0.75, and this is a number less than 1. So that's the probability of happening of that event. And the last one, what is the probability that the arrow stops at a number less than 9? So numbers 1 to 8, all of them are numbers less than 9. So it is 8 out of the 8 options, which is a 1. So probability of getting a number less than 9 is the probability of a sure event. The 13th question, a die is thrown a 1. In that case, I have written the sample space here. The sample space consists of elements 1, 2, 3, 4, 5, 6. Find the probability of getting a prime number. So how many prime numbers are there? 2 is a prime number, 3 is a prime number, 5 is a prime number. So the first bit, probability of getting a prime number is 3 out of 6 cases, that is 1 upon 2. The second question, what is the probability that a number lies between 2 and 6? So here, how many numbers lie between 2 and 6? That is 3, 4 and 5. So these are also 3 out of the 6 cases. And the 13th question, third bit is, what is the probability that it is an odd number? So out of the 6 cases, how many odd numbers are there? 3 is odd and 5 is odd, 1 is odd. So here probability of getting an odd number is also 3 out of the 6 cases. Number of favorable outcomes means how many odd numbers are there? 3 of them divided by total number of outcomes. So 1 die is thrown once, the total number of outcomes is 6. So 1 upon 2, which is 0.5. The 14th question. The question states one card is drawn from a well shuffled deck of 52 cards. Find the probability of getting a king of red color. So let's get started. I have discussed the cards in the beginning part of this video. So what is the probability of getting a red king? So there are two sets of cards which are red in color, that is a diamonds and hearts. So each of them will have one king each. So it is a 2 out of 52, that is a 1 upon 26. Now the second one, what is the probability of getting a face card? So of each kind there are 3 face cards out of the 4 kinds of cards. So king, queen, jack are the face cards. So the favorable outcomes is 3 times 4 over 52, that is 12 upon 52, which is 3 upon 30. Now the third bit, what is the probability that it is a red face card? There are 2 sets of cards which are red in color, and in each set there are 3 face cards, that means 3 diamonds and 3 hearts. So overall 6 face cards out of the 52 cards, which is a 3 upon 26. The fourth bit, what is the probability that the one card drawn from the well shuffled deck of 52 cards is the jack of hearts? Among hearts there is only one jack, so it is 1 out of 52. The fifth one, what is the probability that the one card that is drawn is a spade? So among the category of spades there are 13 cards out of the total 52 cards in one pack. So it is 13 out of 52. The last one, what is the probability of getting the queen of diamonds? Among diamond or diamonds there is only one queen. So one queen in the among diamonds, which is pulled out of the pack of 52 cards. Now coming to 15th question, 5 cards, the 10, jack, king, queen, ace of a diamond are well shuffled with their face cards down. So this time we have only 5 cards in our hand, that is the number 10, a jack, a queen, king and ace, and all of them from diamonds, from the diamond set, are well shuffled with their face cards face downward, and then one card is picked at random. We are supposed to answer what is the probability that the card is a queen. So out of these 5 cards there is only one queen. So probability of getting a queen is 1 upon 5. And the second one, if the queen is drawn and put aside, then what is the probability that the second card picked up is an ace, that is a bit. So out of the 5 cards there is only one ace. So it is 1 out of, earlier there were 5 cards, but one queen card is drawn and it is already put aside. So it is not mixed up. So probability of getting an ace is 1 out of 4, that is the A bit. And then there is a B bit of the question. It says, what is the probability of getting a queen now? There was only one queen. So that queen is already drawn and kept aside. So there is no queen out of the remaining 4 cards. So probability of getting a second queen out of the 5 cards is 0, which is an impossible event. Now the 16th question. The question states 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at the pen and tell whether it is a defective or not. One pen is taken out at random from this lot. We have to tell, or we have to determine the probability that the pen taken out is a good one. How to write this answer? we have to first write the formula of finding probability of happening of an event, and then in the second step we have to write the probability that the pen drawn is a good one as the number of favorable outcomes. So there are 132 good pens out of the total number of pens, that is the good ones 132 plus the 12 defective ones. So it is going to be 132 over 144, and this can be brought to standard form, which is 11 upon 12, and this is less than 1, so this is a correct answer. Now 17th one, it has got two bits. The first bit, a lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from this lot. What is the probability that this bulb is a defective? So probability of getting a defective bulb is the number of defective bulbs out of the total number of bulbs, which is 1 upon 5. The second bit, suppose the bulb drawn in bit 1 is not defective and not replaced. So in this case, we still have the 4 defective bulbs, but the remaining 16 good ones or good bulbs has now reduced to 15 good bulbs. So now what is the number of defective bulbs is now also 4, because in the second bit, according to the statement, the bulb that is drawn in the first bit is not defective. So if it is not defective, then the one that was picked up is one of the good ones. So 4 defective bulbs are still there in the lot, and it is not replaced. So number of defective bulbs is 4, and the number of good ones, which is supposed to be 16, is now 15. Why? Because the one that was drawn is not defective and it is not replaced also. Now let's answer the question. Now one bulb is drawn at random from the remaining rest. What is the probability that this bulb is not a defective bulb? So probability of not a defective bulb is, how many non-defective bulbs are there? They are 15 in number. Out of the total, that is 15 plus 4, that is a 15 upon 19, and this is also a number less than 1, and this is the probability of happening of the event. The 18th question, a box contains 70. The 18th question, a box contains 90 discs which are numbered 1 to 90. If one disc is drawn at random from the box, what is the probability that it bears a 2-digit number? That means from 1 to 90, how many 2-digit numbers are there? So probability of 2-digit number is, from 1 to 90 there are 81 2-digit numbers. So 81 over 90, which is 9 upon 10, and which is 0.9. The second bit, what is the probability of getting a perfect square number? The second bit is, what is the probability of getting a perfect square number? So from 1 to 90, how many perfect squares are there? So 1 is a perfect square, 2, 3, 4 is a perfect square, 5, 6, 7, 8, 9 is a perfect square, 10, 11, 12, 13, 14, 15, 16 is a perfect square, 25 is a perfect square, 36 is a perfect square, 49 is a perfect square, 9 out of 90. So the probability of getting a perfect square is 1 upon 10, which is 0.1. Bit, what is the probability that a number is divisible by 5? So from 1 to 90, how many numbers are divisible by 5? So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85 and 90. So 18 such numbers are there. So 18 out of 90. So 9 table, 9 twos, ultimately 1 upon 5, which is 0.2. Now the 19th question. The question says a child has a dice whose 6 faces show letters given as A, B, C, D, E, A. In a way, the sample space of the outcomes of a dice which is rolled once is shown. The dice is thrown only once. What is the probability of getting bit 1 A and then bit 2 D? So let's answer the first one. Probability of getting a letter A is how many times A has shown up. So there are 2 outcomes out of 1, 2, 3, 4, 5, 6. So 2 is the favorable outcomes out of the 6 total outcomes. So which is a 1/3, which is a non-terminating and recurring decimal of 0.3. The second one, what is the probability of getting an alphabet D when the dice is rolled once? So there is only one D out of the 6 choices or outcomes, so 1 out of 6, and this is also a number less than 1, so this is the probability of getting a D. Now the 20th question. The question says, suppose you drop the 20th question says, suppose you drop a dice at random on this rectangular region shown in this figure 14.6. What is the probability that it will land inside the circle with a diameter 1 meter? So this circle has a diameter of 1 meter, means its radius is 1 upon 2 meter, 0.5 meter. So what is the probability that the dice will fall into the circle region? So probability of the dice falling into the circular region is the area of circle over the complete area of the rectangular region. Because dice is rolled over the rectangular region, the probability that it falls into the circular region we have to find. So the favorable outcome is the area of the circle over the total outcome. Total outcome is the complete area of the rectangle. The area of the circle is a pi r square, that is 1 upon 2 times the area of circle is a pi r square. So pi r is a 1 by 2 times a 1 by 2, and area of rectangle is a length into breadth. So length is a 3 meter and breadth is 2 meters. So 3 into 2. Since pi value is not mentioned, we can write the probability as pi upon 8 3s 24. So pi upon 24 is the probability that the dice will fall into the circular region. In the 21st question, the question says a lot consists of 144 ball pens, of which 20 are defective and others are good. Let us collect some information. So total number of outcomes is 144, out of which 20 are defective. So the remaining are good pens, that is 124. Noori will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. Find the probability, or what is the probability that she will buy it. She will buy only the good ones. So how many good pens are there? So the first bit answer is probability of Noori buying it is how many good pens are there? 124 out of the total number of pens, that is 144, which is 31 upon 36, a proper fraction, so its value is less than 1. So probability that Noori will buy it is 31 out of 36 chances. And what is the probability in the second bit? What is the probability that she will not buy it? She will not buy if it is a defective. So how many defective pens are there? 20 are there out of 144. So probability that she doesn't buy. So I am writing B vinculum just to tell that complementary of buying, that she will not buy, is 20 upon 144, which is 5 upon 36. So these are elementary events. That's why when we add probability of Noori buying the pen, that is 31 out of 36, and probability of Noori not buying it, that is 5 upon 36, they will sum up to 1. Now into the 22nd question. The question says refer example 13.1. So in 13.1 there is the figure 14.3 which we have to refer according to the question. The question says that complete the following table. So in the first line, event is sum on the 2 dice. Here 2, 3, 4 up to 12 it is written. Then we have to write the probability in the second line. So as an example, at some places they have written sum on the 2 dice is a 2. Now look into the this sample space for 2 dice which are thrown once or a single die thrown or rolled twice. So this is a sample space of 36 total number of outcomes. So sum of the numbers on the 2 dice is a 2. So how many such cases? That's only one case. 1 and 1, so 1 plus 1 is 2, so it is a 1 out of the 36. So getting a sum of 2 on the 2 dice is a 1 out of 36 cases. Now we should search for probability that sum on the 2 dice is a 3. So look into this, sum is a 3, so this case which I am encircling, 2 and 1, 2 plus 1 is 3 and 1 and 2, 1 plus 2 is a 3. So these are 2 out of 36 cases. So here probability is a 2 out of 36. Then getting a sum of 4 means here I am encircling 3 comma 1, that is 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. So these are 3 cases out of the 36 cases. So probability of getting sum of 4 on the 2 dice is a 3 out of 36. Now you see how this probability list of numbers is ascending. The first one was 1 out of 36, next is 2 out of 36, next is 3 out of 36. So now we need not see for 5, but still I will show you. So getting a sum of 5. So here I am encircling with green 4 comma 1, 3 comma 2, 2 comma 3, 1 comma 4. So in this list sum of digits or numbers on the 2 dice is summing up to 5. So these are 4 out of 36 cases. Now let's see for 6. So I'm encircling again for 6, that is 5 1, 4 2, 3 3, 2 4, 1 5. This set of numbers when we sum we get 6. And how many are these? 1 2 3 4 5. So on the 2 dice sum of numbers 6 is a 5 out of 36. Let's see for 7. 7 is 6 1, 5 2, 4 3, 3 4, 2 5, 1 6. Sum of this set of numbers is 7. And how many are these? These are 6. 1 2 3 4 5 6. So probability of getting the sum of 7 is 6 out of 36. And instantly after this we are seeing sum of the digits on the 2 dice as 8 has come down to 5 out of 36. Now let's see for 9. For 9 already encircled 1, 6 2, 5 3. Okay, 6 2 is 9, 5 plus 3 is 8, 6 plus 2 is also 8. Okay, this line 6 plus 3, 5 plus 4, 4 plus 5, 3 plus 6. So these are 4 in number whose sum is 8, whose sum is 9. So this is 4 out of 36. Now we see some kind of progression. The beginning was ascending and now it is going descending. So for 10 and 11 we should see the symmetry and write. So probability of getting sum on the 2 dice as a 10 should be 3 out of 36 and 11 should be 2 out of 36, so that sum on the 2 dice as a 12 is a 1 out of 36. The question went for a continuation, the second bit. A student argues that there are 11 possible outcomes, 2 up to 12. Therefore, each of them has the probability of 1 out of 11. Do you agree with this argument and justify your answer? We should agree with this argument. Why? Because 2 to 12 there are 11 possible outcomes. So probability of occurrence of 2 is 1 out of the 11 cases. Probability of occurrence of 3 is also 1 out of 11 cases. So probability of occurrence of each of these individual number is 1 out of 11 possible outcomes. 23rd question. A game consists of tossing 1 rupee coin 3 times. That means here a single coin is tossed 3 times. So total number 2 to the power 3, because one coin is tossed 3 times, so it turns out to be 8, and here is the sample space in form of the box. A game consists of tossing 1 coin 3 times. I am reading the statement again. Noting its outcome each time, Hanif wins if all tosses give the same result. That means 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif loses the game. So let us first see what is the probability that Hanif wins. Hanif wins when there is all heads or all tails. So this is only 2 cases out of 8, that is 1 upon 4. We will apply the probability of happening of an event plus probability of not happening of an event as a 1. So probability that Hanif wins is 1 upon 4. So probability that Hanif loses is 1 minus 1/4, which is a 3/4. So the probability that Hanif loses the game is 3 upon 4. 24th question. A die is thrown twice. A single die thrown twice is same as 2 dice thrown once. So this is the sample space for 2 dice thrown once. What is the probability that 5 will not come up either time? That means when we roll 2 dice once, what is the probability that 5 will not come up at all? So the 5 numbers appear in this as well as this. So we have to remove from the 36 total number of outcomes this set of terms. So the first 5 will not come up is from the 36 outcomes we have to subtract 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of the total 36, that is 25 upon 36. The second one, 5 will come up at least once. So it is the 11 cases out of 36. This is the last question of the exercise, question number 25. It states which of the following arguments are correct and which are not correct, and we have to give a reason for our answer. The first one, if 2 coins are tossed simultaneously. To understand the question, I have kept the sample space in form of this table in the right side. If 2 coins are tossed simultaneously, there are 3 possible outcomes. According to the question, there are 2 heads, 2 tails, or 1 of each. This is according to the question. But according to our sample space, we have 2 heads, 2 tails, a head and a tail in one combination, and a tail and a head in another combination. So according to the question statement continues. Therefore, each of these outcomes, the probability is 1 upon 3. It is correct or incorrect. According to me, it is not correct. Why? Because if 2 coins are tossed simultaneously, then probability of occurrence of each is probability of getting 2 heads is 1 upon 4. Probability of getting 2 tails is 1 upon 4, and probability of getting a single head and a single tail is 2 upon 4, which is 1 upon 2. So none of these probabilities is equal to 1/3. So the first statement is not true. The second bit, if a die is thrown, so if it is a single die it is thrown, I have written the sample space 1 to 6. There are two possible outcomes, an odd number or an even number. Therefore, probability of getting an odd number is 1 upon 2. Is this a correct statement? Let's verify this. In this sample space, how many odd numbers are there? 1, 3, 5. These are the odd numbers. The probability of getting an odd number is 3 out of 6 choices. So it is 1 upon 2, and probability of getting an even number is also 3 out of 6, which is 1 upon 2. So probability of getting an odd number is 1 upon 2. It is true. So it is a correct statement. Let us conclude the video by having a quick glimpse on the summary part. So in the summary, the first point, the theoretical, which is otherwise known as classical probability of occurrence of an event, is written as a P in the bracket E, and theoretical or classical probability of occurrence of an event is calculated using the formula number of total favorable outcomes are divided by total number of outcomes. The second one, probability of a sure event is always a 1, probability of an impossible event is 0. Probability of happening of an event always lies between 0 and 1. If an event has only one outcome, it is called the elementary event, and sum of probabilities of all elementary events of an experiment is always a 1. And the last point, probability of happening of an event plus probability of not happening of an event always sums up to 1. A note to the reminder, let's read this also. The experimental probability, otherwise known as empirical probability. So two terms we have to remember in this chapter. The theoretical probability is called classical probability, and experimental probability is otherwise known as empirical probability of an event is based on what actually happened, while theoretical probability of the event attempts to predict what will happen on the basis of certain assumptions. As the number of trials in an experiment go on increasing, we may expect that experimental and theoretical probabilities to be nearly the same. This is what I have discussed in the beginning part of the video. Hope this video is very useful to you in the preparation for your class 10th board exam. If it is so, consider subscribing to this channel.